Okay, so hey everyone, today we'll be discussing the next question of our DP sheet and which is robot arms 2. Okay, so here you have been given a sequence of positive integers a1, a2 up till an and integers x and y, and we need to determine whether it's possible to place n plus 1 points marked as p1, p2 up till pn plus 1 in the xy coordinate plane to satisfy these conditions. And we are allowed to place two or more points at the same coordinate. So the conditions are the first point should be 0, 0, the second point should be a1, 0, and the last point should be x, y. And distance between points pi and pi plus 1 is ai. And the segments pi, pi plus 1 and pi plus 1, pi plus 2 should form a 90-degree angle. And these are the constraints where n is still 10 to power 3 and ai is surprisingly low, which is only 10. So we'll see how we can use this as a hint to build up the approach to this solution. Okay, so yeah, now let's understand the conditions better. Okay, so yeah, so let's start with this condition. So this says, let's say this is a point pi, this is a point pi plus 1, and say this is a point pi plus 2. Then pi plus 1, this and this should form a 90-degree angle, right? So this is the one of the important conditions. And the other condition is that the distance between pi and pi plus 1 should be ai. So this distance should be ai, this distance should be ai plus 1, and so on, right? Okay, so um, these conditions are just simple. Just we have been given the P1, P2 and Pn plus 1. Okay, so let's start to build up the solution. Foremost, we have been given P1 as 0, 0, and we have been given P2 as A1, 0, right? And one thing to wonder is why have we given two starting points, right? So the main motive can be is that while satisfying the last condition, which is the segment should form a 90-degree angle, one such path is say this, like something like that, where each is 90 degree, each angle is 90 degree, and this satisfies, right? For now, since we have been given this condition that p1 and p2 are fixed and pn plus 1 is somewhere here, which is x comma y, right? So that makes us wonder what could be the next point possible, right? So one thing to note is since this is 0, 0 and this is a1, 0, so this line is parallel to the x-axis, right? Say this is x and this is y, right? So the next line either could be here, either it could be this or it could be this, which is parallel to the y-axis. And again, the next segment either can be this or it can be this or this or this, right? Again, the next segment is again parallel to the x-axis, right? So that gives us a very good hint that each of the segments is either parallel to the x-axis or parallel to the y-axis. Okay. Now this takes us to the conclusion that since each of the segment is either parallel to the x or y axis, right? So in a segment, either only the x coordinate changes or either the y coordinate changes. Both can't change, right? Because since one is anyways parallel to a particular axis, right? So only that coordinate can change. The other coordinate remains same. So since this is parallel to the x-axis, only the x coordinate changes, right? Here, 0 becomes a1. The y coordinate remains same. So this gives us a particular hint that is this even a 2D problem? And is it possible to calculate the x distances and the y distances separately, right? And that's precisely a very good hint to this problem, that we'll calculate the x and y answer separately and just check if both are possible, then we print a yes, else we print a no. Okay, so let's try to dry run this for a generic case. So this states that one thing is that distance between pi and pi plus 1 is ai, which is true, right? And now when we are like thinking of building the second segment, it's either possible this way or this way, right? Since we need to maintain a 90-degree angle. So P3 either can be A1 comma A2, or P3 can be A1 comma minus A2, right? And again, since the x coordinate anyway is same, so this distance again becomes A2, and this distance yet becomes A2, and the 90-degree condition is also satisfied, right? So, and yeah, similarly, let's try to build where can we have the point P4, right? So P4 either can be here, which will be, if we tell A1 plus A3 comma A2, or it can be here, which will be A1 minus A3 comma A2, and similarly it can either be here or here, right? So I hope this gives us a hint of how the solution would look like, and it seems that this brute force solution even works. So let's just dive into the code to understand it better, and then we'll again come back to the explanation. Okay, so here is the code. Here we have taken nx and y as input, and we have initialized two sets, stx and sty, where we'll be separately calculating the x coordinates as well as the y coordinates. And this works because since anyways each of the segment is parallel to the x or y axis, and only one of the coordinate changes, right? So it's even easier to calculate the distance, right? And now we just loop through all the points a1, a2, a3 which have been given the sequence. And if I equals 1, this simply means that the first point P1 is fixed to 0, 0, and the second point P2 is fixed to A1, 0, right? So we have a x coordinate from where we can build up to the further, we can further build up the solution, right? So basically, STX will store all the current x coordinates that are possible, and similarly, STY will store all the current y coordinates which are possible, and from there on, we can further build up the solution, right? So here, since I is 1, so simply P2 is anyways fixed, right? So we just, and now we have a x coordinate A1 from where we can go further. So we just put it in a set STX, and if I equals 2, so this means either we can go P2, P3 can be either A1 comma A2, or P3 can be A1 comma minus A2, right? Both are a distance of A2, which satisfy the condition that the distance between P2 and P3 should be equal to A2, right? So the two possible y coordinates are plus A2 and minus A2, right? So that's what val is just A2 only. In the next iteration, so we add plus A2 and minus A2 to our STY, since these are the possible y coordinates. And from there on, it just becomes very easy, since now since if I is even, we cater to the we had calculated A2, and now we'll be taking input A3 as the input, right? So since if I is odd, we are moving along the x-axis, right? So x coordinate changes. So that's it. If I is odd, next we'll calculate for I equals 3, right? So we take A3 as the input, and simply all the coordinates which were present in STX. These are all the possible locations till where we could have reached, right? And then from here, either we can go to plus val or minus val, right? Or plus val. So that's what we are doing. We iterate the STX, the existing set of coordinates which we could have reached, and we just store all the new coordinates in a new set which is tempx. So yeah, these are IT stores all the, we iterate through all the existing coordinates, and the new coordinates either can be IT plus val or IT minus val. and we just store tempx in stx, and tempx anyways was just a temporary set. And similarly, if I is even, then the segment will be parallel to the y-axis and the y-coordinate changes, right? So sty, we iterate through all the existing y-coordinates till where we could have reached, and from there on, either we could go to it plus var, or we could go to it minus var, right? And that's it for the solution. And in the end, if we could have reached x, right? So if stx dot count, if stx contains x and sty contains y, then we print a yes, and then else we print a no. Now, one major question you might be having is, isn't the time complexity going to be very huge? So let's see what the time complexity can be. Okay, so since we are learning a for loop from 1 to n, and say the set size at max can go till L, right? Then the time complexity becomes O of n, and for each value of I from 1 to n, we are iterating the set, right? So iterating all elements will take, and accessing one element will take log L. So a log L, L log L for iterating all the elements of the set stx or sty, and we are doing this n times. So this is the time complexity where n is 1e3, and we need to find out what the max value of L can be, right? Like what's the range of elements that could be present in the set. So earlier we had seen that apparently AI was only till 10, right? And we are starting from 0, 0. So that tells us that in each n iterations, say we are starting with 0, 0, either a x or y coordinate can at max increase by 10 or decrease by minus 10, right? Either increase by 10 or decrease by 10, right? So after the all the n iterations, we could either reach max, say first iteration we can reach a maximum, say x or y coordinate value of 10. Second we can reach 20, and so on. After 10 raised to power 3 iterations, we can at max reach coordinate of say 1e4, and similarly we can at max reach a coordinate of minus 1e4, right? So this is just a set of 2 into 10 to power 4 coordinates, right? So that's precisely the value of L, which is 2 into 10 to power 4, and log L is again somewhat around 15, I would say. So this definitely, so this just becomes something like, I must say, 3 into 10 to power 7 or 8 sort of a time complexity, and this just passes the solution. So I hope the solution was clear. Apparently it was just like a brute force solution, you might say, and that's it. I hope you understood the solution. I'll link it in the video description, and thank you for watching, guys.